Hi everyone. Today my research topic is about instantaneous management of renewable sources in PV integrated battery energy storage system. So first let us focus on the word renewable energy. What is renewable energy? Renewable energy are infinite sources of energy. For example, solar, wind, etc. It is available in our daily life and it is never ending. So there is a lot of scope in this renewable energy for our power distribution system. It is given to the consumers and industries for energy, for generating electricity to give to the consumers. So let us know what is the importance of this renewable energy. It is an infinite source, as I have mentioned earlier, and it has environmental benefits. That it is non-polluting compared to the non-renewable energy like fossil fuels. This is not polluting at all, and it has low maintenance cost. The PV integrated battery energy storage system, once set up, has low maintenance that is required for generating electricity, and it has low cost of energy. So there are like how we can integrate, how we can produce this electricity with this solar. So here comes the role of photovoltaic integration with battery. The solar cell are integrated with battery. The solar energy that is captured by the solar cells are converted into electricity through the battery. The inverter converts the DC current to the AC current. So there are many issues that is causing in the PV integrated battery energy storage system. Let us look at it one by one. First of all, the lack of power quality occurs, and the intermittency of the sources and the instability in voltage. All these factors are occurring because of the variations of solar power that is integrating in the solar cell. How can this be improved? How can we eliminate these issues that is caused in the PV integrated battery energy storage system, or how can we reduce the energy wastage? How to overcome the issues? There are various methods for this one in my research, and I have found that controlled methods. In controlled methods, the state of charge of the battery is monitored and the battery is charged or discharged accordingly. In schematic algorithm, various mathematical calculations are used based on the demands of energy. In optimizer slicing, various kinds of filters are used for smoothing the analog current. And in modern architecture, post-modern, the rate of energy is monitored and is calculated and forecasted, and the battery is charged or discharged accordingly. But this forecasting happens only every 15 minutes. How can this management? Here the management of energy is for a short span of time and it has a lot of errors. How can this management of energy be achieved within a real-time basis so that we can we can have the maximum efficiency for energy, and as well as we can reduce the energy cost? So management of energy. What is management of energy? Management of energy is nothing but meeting the demands of the consumers at the right amount, generating at the right amount which is needed for the consumers. This charging or discharging so that there is minimum wastage. What is its significance? Energy cost can be reduced. How can it be achieved? There are various algorithms that are used in today's market. Proper forecasting has to be done, like whether the cloud is going to come, whether the sun is going to blow out. All this information has to be first recorded or forecasted, and then it has to be controlled by the battery. So let us first look at forecasting. How forecasting can be done? Using artificial neural networks. The artificial neural networks can be divided as the input layer, the hidden layer, and the output layer. The input layer takes the data such as solar radiance or temperature. These inputs are divided into data variables which are given to the hidden layer. Hidden layer has neurons connected to them. It works just like a human brain. It learns according to the data which is provided. It is interconnected and it is flexible. The word flexible means the weighting factor of each neuron can be adjusted based on our knowledge. So after the learning process it comes to the output layer, and this goes as a circle. So the accuracy can be increased depending upon the reference and the present output scale. And this is how the data can be forecasted based on different data input variables that is given. So the next aspect of having the good management is battery control. Let us know how battery control can be used. For this purpose, I used fuzzy logic control. The fuzzy logic controller, the irradiance and temperature are taken into consideration, and it is given into the PV array, and it is converted as membership functions. Here, this schematic diagram is exactly what is represented in the fuzzy file. Here, the input variables are converted into fuzzy variables, and it is given proper membership functions like Gaussian variables, triangles, depending upon what the data input variables that is given. So the inference main engine is the main controller in the fuzzy logic, which takes decisions based on the knowledge base. The knowledge base is nothing but a set of rules that is assigned in the knowledge base. It uses if-then statements. If a particular situation comes, then do this process. So in this way, based on different inputs that is given to the fuzzy logic, it calculates and proper output is given. And this goes in a loop and the proper controlling is done. And if there is a variation, it varies accordingly. So how can this fuzzy be implemented in an inverter? So for this purpose, the PV array, as I have mentioned, captures the sunlight and converts it to DC value, and it's given and is stored in the battery. So the inverter converts the DC to the AC signal, and it is passed through a filter. So the fuzzy logic control signal comes here, and it produces the pulse width modulation signals to the inverter to control or to produce smooth output at the inverter. So for this purpose, this is done by taking the input variables and comparing it with the reference variables and generating an error signal. The error signal controls the PWM signals, the pulse width modulation signals. If the error signals are more or positive, the duty cycle of the pulse width is more, and if the error signals are less, the duty cycle is less. And in this way, the inverter, the switching process of the DC can be controlled, and a smooth analog current can be produced. And this is further done smooth by using LC filters, which again smooths the signals and produce the output at the load. So what are the disadvantages of the existing systems? In the existing systems, it cannot measure the transient changes, the sudden fluctuations that is occurred in the solar. The output varies according to that. So my design was how to overcome these transient changes in the solar. So I thought of implementing two control systems which simultaneously transfers data in a bidirectional manner. That's artificial neural networks forecasting is done here. At the same time, the battery is controlled with the fuzzy logic. So the inputs given to these systems transfers data, and if there is a sudden variation, the controller can immediately transfer data and the battery can be controlled accordingly. This way, I think it can overcome the process of transient changes that is occurred, the sudden fluctuations, the sudden voltage increase that is occurred in the PV integrated system. So let us look at what are the advantages of this. It is definitely an instantaneous management of energy. As I mentioned, it happens in a real-time basis. It is a fast controlled response. The logic used are then purely based on certain rules and inputs. Depending upon the inputs, output are produced. It is very fast and it is flexible. These rules can be changed according to our needs, and so it is a very flexible option for both artificial neural networks and fuzzy control. And it is a whole lot of reduction of energy because the responses are made same instant. What are the disadvantages? Of course, it's a complex design. Like I have used two algorithms at the same time, and it can be expensive also. That is all for today. Thank you.